Fluids in a formation are under pressure. When drilled, this pressure can escape to the surface if it is not controlled. Normally, drilling mud offsets formation pressure. That is, the weight or pressure of the drilling mud keeps fluids in the formation from coming to the surface. For several reasons, however, the mud weight can become lighter than is necessary to offset the pressure in the formation. When this situation occurs, formation fluids enter the hole. When formation fluids enter the hole, this is called a kick. A blowout preventer stack is used to keep formation fluids from coming to the surface. These are called BOPs. By closing a valve in this equipment, the rig crew can seal off the hole. Sealing the hole prevents more formation fluids from entering the hole. With the well sealed or shut in, the well is under control. Rig crews use a surface BOP system on land rigs, jackup rigs, submersible rigs, and platform rigs. They use a subsea BOP system on offshore floating rigs, like semi-submersibles and drill ships. Why do you suppose subsea BOP systems are used on semi-submersibles and drill ships? Blowout prevention equipment is very large and very heavy. Semi-submersibles and drill ships are dynamic, that is, they float and thus move with the wind and waves while in the working mode. On floating rigs, it's not practical to mount the BOP stack on top of the long riser pipe. The BOP stack is much too heavy for the relatively thin and flexible walls of the riser pipe. Also, because the riser walls are relatively thin, they cannot withstand the high pressures that could develop inside the riser when the well is shut in on a kick. So the rig crew mounts the BOP stack on the wellhead at the seafloor and makes up the riser on top of the stack. A blowout is dangerous. Formation fluids like gas and oil blow to the surface and burn. Blowouts can injure or kill, destroy the rig, and harm the environment. Rig crews therefore train and work hard to prevent blowouts. Usually they are successful, so blowouts are rare. But when they happen, they are spectacular and thus often make news. A kick is the entry of formation fluids into the wellbore while drilling. A kick occurs when the pressure exerted by the drilling mud is less than the pressure in the formation that the drill string is penetrating. The mud that circulates down the drill string and up the hole is the first line of defense against kicks. Drilling mud creates additional pressure as it circulates. The mud pressure keeps formation pressure from entering the wellbore. On the rig, they say mud keeps the well from kicking. Sometimes, however, crew members may accidentally allow the mud level or mud weight in the hole to drop. This drop in weight or level can happen for several reasons. For example, the crew may fail to keep the hole full of mud when they pull the pipe out of it, or they may pull the pipe too fast, which can lower the bottom hole pressure. When the mud level or mud weight drops, the pressure exerted on the formation decreases. If either happens, formation fluids can enter the hole. If they do, the well takes a kick. In other words, when the formation pressure exceeds the weight of the mud column, then the well can kick. To keep a kick from becoming a blowout, the rig crew uses blowout prevention equipment. The blowout preventer, BOP stack, consists of several large valves stacked on top of each other. These large valves are called blowout preventers. Manufacturers rate BOP stacks to work against pressure as low as 2,000 pounds per square inch, or PSI, and as high as 15,000 PSI. That's about 14,000 kilopascals to over 100,000 kilopascals. Rigs usually have two kinds of preventers. On top is an annular preventer. It's called an annular preventer because it surrounds the top of the well bore in the shape of a ring, or an annulus. Below the annular preventer are ram preventers. The shutoff valves in ram preventers close by forcing or ramming themselves together. The choke line is a line through which well fluids flow to the choke manifold when the preventers are closed. Even though the preventers shut in the well, the crew must have a way to remove or circulate the kick in the mud out of the well. When the BOP shut in the well, mud and formation fluids exit through the choke line to the choke manifold. The manifold is made up of special piping and valves. The most important valve is the choke. The choke is a valve that has an adjustable opening. Crew members circulate the kick through the choke to keep back pressure on the well. Keeping the right amount of back pressure prevents more kick fluids from entering the well. At the same time, they can get the kick out of the well and put in heavier mud to kill the well, that is, regain control of it. The well fluids leave the choke manifold and usually go to a mud-gas separator. A mud-gas separator separates the mud from the gas in the kick. The clean mud goes back to the tanks. The gas is flared or burned a safe distance away. When the well takes a kick and the BOPs are open, well fluids force mud to flow up the well bore and into the BOP stack. When the driller closes the annular BOP, flow stops. Usually, drillers close the annular BOP first. The closed annular BOP diverts the flow of the choke line, which goes to the choke manifold. The driller can open a valve on the choke line and safely circulate the kick out of the well through the choke manifold. Here's an annular preventer. Click on it to see how it works. An annular BOP closes on drill pipe, drill collars, or any shape of tubular in the well. It can also close on open hole, a hole with no tubulars in it at all. It's usually the first preventer used to close in the well. Here are 4 types of ram preventers: pipe rams, blind rams, blind shear rams, and variable bore rams. Click on each one to see how the rams work. Pipe rams are used when there is drill pipe in the BOP stack. The pipe rams fit around the pipe, closing off the annulus. Pipe rams back up the annular preventer. That is, in the unlikely event that the annular BOP failed, crew members could shut the pipe rams to seal the well. Also, some pipe ram preventers are used to hang off or suspend the drill string on subsea BOPs. Blind rams are designed to seal an open hole. If the annular BOP fails, and there is no pipe in the hole, the crew could seal the well by closing the blind rams. Blind shear rams are designed with blades that cut through the drill pipe and then seal the open hole. They are used in extreme emergencies, like when an offshore floating rig has to move off a well they're drilling because of a hurricane or other such emergency. Blind shear rams allow them to cut the pipe, seal the hole, and then move the rig a safe distance away. Variable bore rams, or VBR, are special pipe rams that can close over a range of pipe sizes, such as 5-inch diameter to 3-inch diameter. Here are the major parts of a land, jackup, platform, or submersible rig's blowout prevention equipment. The blowout preventer, or BOP stack. The driller's BOP control panel. The BOP operating unit accumulator. The choke manifold. The choke control panel. mud gas separator, the flare line and flare pit, the trip tank, and drill string valves. Pop quiz. You've just learned the names of the equipment used in well control operations. Let's see how well you can identify the equipment. From this BOP control panel, the driller opens and closes or controls the blowout preventers and the line to the choke manifold. Rig builders usually place the control panel on the rig floor, close to the driller's position. Levers and switches allow the driller to quickly open and close the preventers and other valves in the system. The accumulator bottles store or accumulate hydraulic fluid under very high pressure, up to 3,000 psi, over 20,000 kilopascals. This high-pressure fluid ensures that the preventers close very fast. The BOP operating unit accumulator is installed some distance from the rig floor. When the driller activates the BOP operating unit, it pumps the hydraulic fluid through the high-pressure pipes or lines into the BOP stack. The hydraulic pressure opens or closes the preventers. Usually, the driller operates the accumulator from the control panel on the rig floor. In an emergency, however, crew members can operate the BOPs by using the control valves on the accumulator itself. Here's a choke manifold. Flow gets to it from the BOP stack via a choke line. The manifold usually has 2 or more special valves in it called chokes. Usually well flow goes through only one of the chokes. The others are backups or used under special conditions. By adjusting the size of the opening in the choke, making the opening larger or smaller, the driller adjusts the amount of flow through the choke. The smaller the opening, the less flow. The larger the opening, the more flow. The less flow, the more back pressure on the well. The more flow, the less back pressure on the well. This adjustment of back pressure keeps the pressure on the bottom of the hole constant, so that no more kick fluids can enter the well. The driller or another crew member uses the choke control panel to adjust the size of the choke's opening as kick fluids flow through it. By watching the pressure on the drill pipe and casing, and by keeping the mud pump at a constant speed, the choke operator can adjust the choke to keep the pressure on the bottom of the hole constant. The choke operator must keep the bottom hole pressure constant to successfully control and circulate a kick out of the hole. Often, kick fluids and mud from the choke manifold go through a line to a mud gas separator. Frequently, formation gas is the main part of a kick. However, kick fluids may also contain water, oil, or a combination of these fluids. In any case, the mud gas separator removes the gas from the mud. With the gas removed, the pump circulates gas-free mud into the mud tanks and back down the hole. The separated gas goes to a flare line. In the separator, mud with gas in it from the choke manifold enters the top and falls over several baffle plates. The gas breaks out of the mud as it falls over the baffle plates and goes into the flare line. The gas-free mud falls to the bottom outlet, where it goes to the mud tanks for circulation downhole. The flare line conducts gas from the mud gas separator to a flare pit on land rigs. The gas is burned or flared at the flare pit. Notice that the flare line outlet is a good distance away from the rig floor, so even while gas is flaring, the crew can still safely work on the rig floor. Offshore, where there's no flare pit, the flare line conducts the gas over the side of the rig. The line runs over the water, a safe distance away from the rig. A trip tank is a special mud tank. It is used when they pull drill string from the hole, for example, to change out a dull bit. They also use a trip tank when they run drill string back into the hole. Pulling the drill string and running it back in is called a trip, which is why they call this small tank a trip tank. They use it to keep accurate track of how much mud the drill string displaces in the hole. When the crew pulls drill string from the hole, the mud level in the hole drops. If they let the mud level drop too far, it won't exert enough pressure to keep formation fluids from entering the hole. So, as the crew pulls pipe, they continually circulate fluid from the trip tank to replace the drill string and keep the hole full. They also watch for unusual changes, and they make sure that the volume of mud they put in exactly replaces the volume occupied by the drill string. Since the volumes are small, the level of mud in the trip tank is calibrated in small increments, such as stands of pipe, or barrels, or liters of mud, or both. If the volume they put in is less than the volume occupied by the drill string they removed, then it's likely that formation fluids have entered the hole. For example, let's say the crew pulls one stand of drill pipe. In this instance, the stand displaces 0.7 barrels or 111 liters. Therefore, they should pump 0.7 barrels or 111 liters of mud to replace the stand. The mud level in the trip tank should show a drop of 0.7 barrels or 111 liters. If the level in the tank shows less, then formation fluids have entered the hole, and the crew must take steps to control the well. The hole drops. If they let the mud level drop too far, it won't exert enough pressure to keep formation fluids from entering the hole. So, as the crew pulls pipe, they continually circulate fluid from the trip tank to replace the drill string and keep the hole full. They also watch for unusual changes,